Hi 8th graders, today you guys will be going over the review to help you guys get prepared for our test in the next week. This should take you, obviously this is your full day lesson for today that you guys are doing at home, and you might have a little block of time next week when you're watching a video about bocce ball to help you guys or give you guys some time to complete this review. So for this review you guys will need to open Amplify and use the simulation. So go into Force in Motion, Chapter 3. Lesson 3.2, and if you open activity 3, you'll see it's a sim, and right here is your 3.2 activity 2 linked to the sim, or activity 3. So your sim, obviously you guys should see this, looks like this. This assignment for today is somewhat similar to the bocce ball assignment if you guys did that remotely. If you did it in class, it's slightly different. But with that being said, you guys are collecting a lot more data and you're being a lot more specific with what you're trying to accomplish in this sim. So this whole review should help you guys get ready for the test. So we're talking a lot about changes in force and how that affects motion in the first part. And then the second part, you're really talking about Newton's first, second, and third law, which we've been studying week or so. Okay, so with that being said, let's take a look at the first part. I did an example for you, and then I'll look just briefly with you guys and do the second part a little bit too. Okay, so what you guys have is this first example that says demonstrate the fact that a force is required to change the velocity of an object. So a single puck in motion or at rest. So like I said, I did this example for you guys so you don't have to do anything on number 1, but I am going to show you guys what I did. So I have my setup here. It looks like I started out with a puck in motion. So if you guys have a snipping tool on your computer, for the setup, I'm cool with you guys snipping a picture of what your puck looks like, okay? This should show you the force I exerted, and it should also show you if you have any velocity or not. In this case, I had my puck already moving, so it should show the velocity of it moving prior to me exerting a force. Okay, if you guys don't have that or you just think it's easier, you guys can just verbally describe how you set it up. The puck was moving to the right, and as it was moving, I applied another force to the right. Okay, so in this case, I started my puck out. If I look, I have to remember what I did. My initial velocity was 3. So I started my puck out, clicking on it and saying my horizontal velocity was 3. Okay, so that should mimic what the picture had. I hit run and then I hit pause and prepare force really quick. Okay, and then it says that I exerted a force of 2 newtons and then my direction was to the right. So 2 newtons in this case would be 2 clicks to the right. Okay, so that showed my force. This is what I screenshotted. This is how I prepared my test. Okay, and then I'm going to go ahead and click exert force and go to analyze. You'll get the rest of your numbers off of analyze. Okay, from this little table right here. All right, so with that being said, my initial velocity, like I said, I had set it at 3 meters per second to the right. Remember that velocity should include a direction, so you shouldn't just say 3 meters per second. So you guys, if you do not put your direction with it, okay, it says right there, don't forget direction with velocity. You guys are going to lose credit for that. It's not going to be complete if you guys aren't including a direction with your velocity. Okay, so initial, if I forgot what I set my initial velocity as, I can go and look and say, all right, horizontally, I started with 3 meters per second. Okay, then I go back in my review, final velocity, so don't forget the direction as well. I can look and say, all right, under analyze, horizontally, my current or my final was 5 meters per second. So I would include that right there, 5 meters per second. I forgot something important there, so I'm going to say to the right. And finally, change in velocity. So how much did it change by? It's pretty obvious where you guys see which direction your initial and your final are going, so I don't really have to include a direction on that. So my change would be 2. You guys might see a negative number in change. What that would mean is you guys also have a change in direction. So maybe I started with 3, I finished with, so maybe 3 to the right, and I finished with maybe 5 to the left. I would see a negative number here for my change. It would be a lot bigger than 2, but I'd see a negative number there. So keep in mind that when you guys have a negative change in velocity, it means that it started to move in the other direction than what it was originally going. Okay, so you guys can include negatives is fine, but you can also just include that it's moving in different directions in your initial and final velocity. Okay, so you guys will do that same thing for the rest of these objectives. Demonstrate how a stronger force can cause a greater change in velocity. So compared to objective 1, add a stronger force. Okay, instead of 3 clicks, add more than that. Demonstrate how an object can speed up. So do a single puck in motion and then make it speed up. Okay, I don't care how much it speeds up by, but that should be reflected in this right here. Demonstrate how an object can slow down. So again, show me your data there. Demonstrate how an object can change direction. Again, demonstrate that you guys can do that with your data. Demonstrate how an object can stop. Demonstrate that with your data. Demonstrate the fact that if the same force is exerted on 2 objects, but the objects have different masses, the object with less mass will have a greater change. So you're going to have 2 single pucks in motion, so you guys can line them up right over top of each other, and then set your force onto those. So each with a different mass, you're not having them collide. So tell me how you set it up, or take a screenshot, and then collect your data for each of those. Okay, and then demonstrate the fact that when 2 objects collide, so now we're talking collisions, a force is exerted on each other. The 2 forces are exerted in opposite directions, but they have the same strength. So you're going to make 2 pucks colliding. So how would you set that up? And then let's talk real quick about the force of A on B. So if you had your puck A on the left moving to the right, and your puck B on the right moving to the left, and they collide in the middle, the direction of the force of A on B would be to the right. Your direction of your force from B on A would be to the left. Okay, notice how those 2 are opposite directions. Now let's talk about the size of the force. If A puts a force of 3 newtons on B, then no matter the size of the object, B should put a force of 3 newtons back on A, but in the opposite direction. Okay, and then finally, demonstrate that even though the force exerted on each object in a collision is the same strength, if the objects have different masses, their changes in velocity will be different. So, same thing you did last time, except now use a heavier puck and a lighter puck. You guys can choose whatever pucks you use as long as they are different masses. You should still see Newton's third law in there, that for every collision you have a force exerted on each other that's equal and opposite. Okay, finally your review questions that hinge all around Newton's first, second, and third laws. You guys will need to go to your notes for this. So go into your OneNote. You guys should have added a section in your OneNote for Newton's laws of motion. So as mine is pulling up, you guys will see on the left-hand side under section, it's under force and motion, and we should have added a page that says Newton's laws for motion. And you guys should have added notes on Newton's first, second, and third law. So use those because they will help you. I would not suggest Googling them because you guys might get more complicated answers than you need for this simple question. So you have this scenario, you have 2 little siblings. The older of the 2 is 10 years old and weighs about 75 pounds. The younger is 6 and weighs about 45 pounds. Both are really annoying. Okay, so which sibling has more inertia, the older or the younger, and why? The answer to that one is in Newton's first law, so read about inertia there. Okay, I'm going to let you guys read through the rest of these. These are very similar to the questions you will see on the test, okay, as are these. So make sure you guys do a good job on this. Let me know if you guys have any questions, and this should help you prepare pretty well for the test, especially if you use your notes. Hope you guys are having a good day. I will talk to you soon. Bye.